How do you implement search parameters in FHIR using Python? So we have already taken a look at how to build a FHIR facade using Python. If you haven't, just take a look at that video. A lot of people get stuck when they start implementing search parameters. So in this video, we'll do a complete breakdown of what FHIR search parameters really mean and how you can implement this in your own FHIR server. So now I already have the FHIR facade code written here already. So we've done this in the other video. Do check it out if you haven't. But basically what this does is, again, I have a Postgres database running here using Docker, and I've already pre-populated that with some information about 4 patients. Now, this app, let me run this app. So this is a FastAPI app. Once I run it, let's just go to Postman here and then test what this looks like. So if I do localhost 88,000/patient, I get all of my patients back in the FHIR format, right? So I'm able to get this JSON. Now, what I'm going to do is we would like to implement search on this. So let's say we want to search them by, let's say, a particular given name, or maybe just a general name. I just want Alice, right? How do we do this? So right now, obviously, it returns all of our results. There is no specific search parameter going on. But let's take a look at how we can do this using our app. So before we get into implementing this in our application, let's actually take a look at the FHIR search functions, right? Like, how does FHIR expect search to be implemented? Because this is not really that straightforward. Let's make this a little bit bigger. So if you take a look at, for example, the patient resource here, right in the bottom, and there is also a separate section for search params. But if you just scroll down to the bottom, you'll see a bunch of search parameters that this resource needs to support. For example, you have active, address, address city, and so on. Now, the type of search parameter is super important, and it really dictates how search should behave. Right? So for example, you have things like string, token, date, and so on. So let's take a simple one first. So let's try to do the given name, right? So a portion of the given name of the patient. So this is just like patient.name.given. Let's take a look at what string really means. Now here they explain what a string match is supposed to do, and there are also modifiers on this search. So for example, you can say given and then a colon and then say contains, or given colon exact, right? Each of this will have a different way in which this behaves. So here's a good quick example of what we really need to implement. So let's say there is given equal to Eve. You're only supposed to match patients that start with this given name. So you are supposed to match Eve and Evelyn. And then if you say given contains Eve, then this Eve can be present in anywhere in the given name. So for example, you would also match Severin along with Eve and Evelyn. Right, Severin, yes. And then if you say given colon exact, then you are supposed to match only the exact name of Eve, right? So let's take a look at how you would do something like this in Postgres first, right? So let's go back to our code base, and I'm gonna open up a Postgres shell. And I'm inside the Postgres shell. So let's actually try to do this ourselves. So we have a few patients. So let's select star from patients. And we have John, Jane, Alice, and Bob. Let's try to figure out what kind of queries we would first write in order to get this functionality, right? So the given equal to Eve. So let's try to implement that first. So what I would probably do is select star from patient where first name, and again, you need to remember that you have to translate the given into the column that is available in your particular database, right? Because we are translating the HTTP request into SQL queries. So we are selecting star from patient where first name equals, let's say, let's do John, for example, right? So this is the easiest way to just get started, right? So you get John. But since this is a string search parameter, what is expected is that it should also match if something starts with John. So for example, even if they type something like JO, you need to match it with John. And in this case, this doesn't really work. And this is where the Postgres I like search parameter comes in, like query option comes in. So let's quickly take a look at what I like does. So here's a quick summary. So you can basically use this like you can say where first name I like, and then you can start with something, and then you can put a percentage sign to match anything that comes after it, right? So let's take a look at how we can use this. So we just say I like JO, that is the thing that they're searching for, and then we say percentage. So this will match anything that starts with JO. So we should get John back, and we do. And we can even say just starts with J, right? And you will get both John and Jane, right? Super simple. So this is literally how you would do something like this, just the given, right? Like if you just want given as a string, you want to match everything that starts with a particular parameter. Now, what if someone asks you to do given and then there is a modifier for contains, right? Again, the I like operation comes in really handy because you can also do percentage. And it's also important to note that this is supposed to be case insensitive. So they tell you that this search is insensitive to casing and included combining characters like accents and other whatever, like if you have a quotation or something, you just put that in the search as well. But this needs to be case sensitive. So let's try this again. But this time we are basically searching for anything that has J anywhere in the name. It can be in the beginning, it can be in the end. And again, it matches John and Jane Doe, but we can be a little bit more specific. So for example, let's say we want something that has an E, right? Something that contains an E in the middle. We'll just do E like this. And then we say that Jane and Alice both have an E somewhere in the name. So that sort of matches. So that's it. Like this is basically how you would do the contains. And then finally, the exact is exactly like what we started off with. So we would do first name equals John, right? And you get exactly this match. But then this also has to be case insensitive. So let's say equal to John, but this doesn't quite work. So we need to somehow make this the same casing, right? So let's see how you would probably do that in Postgres, right? Postgres case insensitive search, right? One option is, again, you can do this where lower name equals lower something. So you are converting both of this to the lower case. But I like another trick, which is, again, just using I like again. And then you just say, I like John. There is no matching pattern here. So it basically will only match John. And you will again get this back. So this is quite a handy function that you can use. But now we have gotten the SQL part working. Let's figure out how to actually implement this in our code base. Okay, now that we are done with the SQL part of this, let's actually try to implement this in our FHIR facade, right, in Python. So now the app.py file is the only file that we have to deal with. We already have a GET request going in for /patient, and this is exactly what's getting us these 4 patients in a bundle. Now we can actually just reuse this exact same logic, but we'll just add a few more search parameters, right? In this case, let's actually start with given, right? So let's take a look at how we will implement given. So I'm going to pass this as a parameter. So let's say given, and then I'll say either string or none. And by default, it's none. So this is a way to make it an optional search parameter instead of making it mandatory. So now usually I just do select all from patients and then I parse it. But then if there is a given, then I need to process that, right? So I will say if given, what I'm going to do is I'm going to say cursor.execute, select star from patients, but then I need another where clause, right? Where I say where given, no, sorry, it's not given. In our table, it's actually called first name, right? So we need to say where first name. And in here, we again need to keep in mind that this needs to start with this name and not just like match it exactly. So we need to use the I like parameter here, like I like operator. And in here, let's say we use a string variable, right? Like we use f strings here and then we pass this in as another variable. And again, this is super important to avoid SQL injections. If you just pass it in directly, then someone can pass in maybe like a semicolon, drop all tables, and then you will have SQL injections. By using parameterized queries, you completely avoid the risk of SQL injections. So here I would again use the F string, and I would pass the given. And again, I need to cover it in quotes. And then I would put another percentage. So this basically means anything that starts with given, let's do that, I like, and then you execute that if the given is present. If it's not, then no worries. You just execute everything and then you return all the patients. Okay, let's test this out. So we again have a patient here called John. So let's actually say J given equals JO, and we get John back. Let's actually try this for something else as well. Let's take a look at our patient Doe, and then let's try given equals DO. And that doesn't quite work. So actually, let's see. Oh, that's the family Doe. So this is John Doe. Okay, sorry. So I think it only matches on the given names. So this should also work with John and Jane if we say given equals J, right? Because both of them start with the J, and we get two results, and we get both John and Jane. So this works perfectly as expected. But let's also try to implement some of these modifiers, right? Like usually people just show you how to do one particular search parameter, but let's go in a little deeper and try to implement different variants of the given search parameter. So what I'm going to do is, again, this doesn't really work in FastAPI. I can't just say given colon something, because it's actually not valid Python syntax to say something like this. So instead, what we are going to do is we are just going to parse the request ourselves. So let's say request. Let's give this the type of request. Let's import this from FastAPI. And in here, let's say request is request. And we are actually going to try and get the given colon contains as a variable here. So let's say request dot search. It's called query params dot get, and we'll get the, let's see what it's called. It's called given colon contains. So I'll just call this given underscore contains. And if this is present, then what I want to do is if given contains, then I actually want to do this anywhere in between, right? So it's going to be something that looks like this, and it's going to be called given contains in here. So where first name I like, given contains, right? So again, let's try this out. So let's say I want all names that contain an E, right, which is probably very common. Given contains, and I get all three results back. So that's Alice, Jane, sorry, it's only two results. That's the number 3 ID here. So that's Jane and Alice. Both of them contain an E. Let's see all the names that contain an S, nothing. And J, so we again get John and Jane. So works perfectly. This is the SQL query. So finally, let's also try to do given colon exact, right? So let's try. It's again like very similar logic in here. So given underscore exact. Then let's just do exact. Let's copy paste this. So this actually has to be an elif statement, because if we don't want to execute this, we only want to execute this if this is there. And again, you will notice this in some FHIR queries. You'll have multiple search parameters. You always have to AND them together and then finally execute one single query. This is a simpler example because we are just dealing with some fields here. But usually what you do is we take all the queries and then you finally construct your SQL statement. And you usually don't want to do these if-else conditions. But for our use case, our data model is quite simple. So we can just do elif given exact, and then let's again do this. And for the exact, it's actually going to be a super simple query. Just pass the exact name using I like. And we use I like here only because it's case insensitive, right? It may be more efficient to do the lowercase conversion of both and compare it, but I think this is okay. So given We don't need an F string here, actually. We can just pass given exact, just like that. Now, it'll only match someone if it's exactly equal to that particular thing. So let's actually quickly try that out. So given exact equals, let's say, Jane, right? And we only get one result, that's Jane Doe, right? And we can try JAN, and it doesn't match, okay? But if we say just given equals JAN, then it matches Jane Doe. So we more or less have our search parameter for name for given working, but that's actually not all. Like, so for example, if you take a look at the search parameters, there is one search parameter that's for name, but then there is another search parameter for family, but there is yet another search parameter just called name. So what they actually tell here is a server-defined search that may match any of the string fields in the human name, including family, given, prefix, suffix, and or text. Right. So in this case, let's also try to implement this. So name is a simple, string. So we can put this in here. So we can say name. It's a string or none. By default, it's none. Let's just give this a space in here. So if we get a name, what we actually want to do is, again, let's just add that as an elif statement here. Name. Then we want to execute all of this, and we want to use the same logic as given, but then we want to check both the first name and the last name, right? So we haven't done this in SQL, but then it's going to look something like select star from patients where first name, I like John, and anything that comes after John, or last name, I like John. It's exactly the same thing. And you just pass both of this in here, right? So this, let's see what this returns is. Again, like returns John Doe, but here we need to pass in two parameters, right? So one is for the first name match and the second is for the second name match. So if there is name, so you have a select star from patients where first name, I like this, or last name, I like another string, right? So let's do, this is name given, and then we just repeat the exact same thing. It's not any different if it's in the first name or the last name. But here it's not going to be called given, it's actually going to be called name. Right, so this will match it regardless of where it finds it in the name. So let's actually try this same query. So we are already running our dev server. So let's go back to Postman and let's just say name equals JAN. So that gives us Jane. But then let's try DOE, and we see that we get two entries and we get both John Doe and Jane Doe because it's somewhere in their name. Let's just try J, and this has to start with J. So we get John and Jane again. And you can keep going like this. So this is, again, like we are just scratching the surface of what's possible with FHIR search parameters. That are, again, like a lot of different search parameters available. But then if you look at a specific profile like US Core or, like a particular implementation guide, then they usually have only certain search parameters implemented. So for example, if you take US Core, implementation guide. So let's go to the patient profile in here for US Core. They have all of this terminology bindings, all of that, but then they only have a few search parameters that are mandatory, right? So they have, you need to search by _ID, you need to be able to search by identifier, you need to be able to search by name, birth date, and then finally all of this is optional, right? You can support it if you like. So it's actually quite practical to implement something like this on top of your own database, and it's pretty easy to get this done. You just need to make sure that you handle all of the different searches well, and finally, again, you need to add this back to your capability statement saying that you do support these search parameters, right? So yeah, I mean, this is, we saw how to create your own search queries for each search parameter. And again, it's not as easy as it seems. That you need to convert all of this into a SQL query. The alternative to this is, again, you can just take all of your data and dump it in another FHIR compliant server and just call it a day. And we've seen, like, we'll see how to do this in other videos. But yeah, just let me know what you think. Let me know down in the comments below if this video has helped you. And we will also leave a link to the whole code that we've done here, and along with other resources. So if you're interested in that, just like let me know down below. I mean, there's a link, you can click on that and we'll just send you all of the resources. So thanks again for watching. I'll see you in the next one.